Right, I've got many hats. I'm a composer. I've written music for live performance, for the BBC, for adverts and things like that, but I'm also a professional developer. So I've worked for Steinberg and consulted for startups, and I run my own non-profit organization now, which is where these projects sit. And that's all about supporting learning and creativity in and through music technology. And it's especially about supporting code literacy, so widening participation in code, especially for musicians. I'm a researcher. I did my PhD at Cambridge in supporting virtuosity and flow in computer music and how we design music software to be more immersive, to support learning, and to support motivation. And basically, if you do all of those things, first of all, you're happier. And second of all, you should be more creative. So I'm kind of unique, or rare in the kind of academic area, is that I look at what you guys do. I'm not about new interfaces for performance or anything like that. I'm about mainstream computer music practice, looking at it and how we can do that better, what opportunities there are, what new technologies there are. So I even, when I design a new interface, I grab a QWERTY keyboard and make it velocity sensitive. So, psychology, right. So there's just a couple of ideas that I want kind of sitting in the background when I talk about these questions and these technologies. Who's heard of flow? Okay, flow is a mental state that you get into, sometimes called being in the zone. So us developers, we sometimes call it hack mode. And basically, it's a total focus. You're absorbed in what you're doing. You're very, very productive, very, very creative. And so it's a proper psychology framework. It's been studied extensively. And one of the most important aspects of it, and one of the important prerequisites of it, is if something you're working on is too challenging for your ability, that's bad. You get anxious. But if your ability is too high for what you're working on, you get bored. Okay, and so you've got to stay in that flow channel to be engaged and to be immersed in what you're doing. And so this flow framework and this flow concept is, it's a framework for usability and a framework for pedagogy, for learning and developing ideas and for getting users more engaged in programs. Okay, so it was developed by Mihaly Csikszentmihalyi in the 90s, and I've been looking at it in the context of music, human-computer interaction, basically since then. You need a balance of challenge and ability. You need the direct and immediate feedback with whatever you're working on. This is really, really important. Feedback is so central to the systems we design if we want them to feel live. And you need focus and concentration, and part of that is brought by the user, but we can also do things in our programs to encourage that. And the most important thing we can do in our program to support focus is not to break focus. Okay, creativity and flow and things like that, very hard to support them, very easy to kill them. So what you'll get is basically what you're working on will become your entire world. Okay, you're just completely absorbed in what you're doing. This gives you a sense of control and autonomy. What happens is that the rest of the world just ebbs away. It just doesn't exist anymore. And one of the lovely things about that is it's a completely egoless state. So in other words, you're not judged by other people, you're not even judged by yourself. So you don't worry about that kind of thing. And again, it's a positive mental state. You are intrinsically motivated by what you're doing. You're not worried about, oh, I've got a deadline, or I need to pay the rent, or anything like that. And this is what motivates the very best creativity. It's what motivates the deepest learning. And Csikszentmihalyi concluded that not only does it foster creativity, it is the happiest we'll ever be, okay, when we feel at one with whatever we're working on. How do you know it's going on? You start working on something and it's 4 a.m. suddenly, okay? So if you've had any users who email you to say, this is an email I had, I love your software, but I'm losing time to it. I can deal with that kind of negative feedback, actually. That's quite nice. But it's a sign that they've got into flow, and it's very close to addiction and dopamine, so there's a little bit of dodginess in there as well. Okay, the other concept is liveness. And this is all about the feedback side. When you're working on something, how far away are you from getting feedback on what it's going to produce? And so this is a recipe for notation use. When you're interacting with music or code or interaction, and you're interacting through a notation, how far away can you get the feedback on it? Can you run it immediately, that kind of thing? This is an idea from the psychology of programming. Again, from the 90s and Steve Tanimoto, who articulated 4 levels of liveness. The first is, it's informative, but you can't run it. Okay, flowcharts, block diagrams, and things like that tell you about the problem, allow you to reason about it, but you can't run it. Okay, so very low liveness. The second one, which is where most of us live, is it's executable. You work on the notation, get it just right, hit, run, build, play, whatever, then you get the feedback. Okay, still quite low liveness. Okay, it's level 2 liveness. The next one is the feedback it's much shorter cycle. It's basically you do 1 edit, 2 edits, then you see what effect that has, okay? It's rarer. It's what we see in live coding, okay, where you write something and you trigger that line of code to execute. And you see it in some kind of doors and things like that, these really rapid feedback cycles. My research basically is about looking at the myriad feedback loops that we have in notation-mediated software, all software. Okay, because software, visual software is notation, okay? But you're trying to get to do a domain. So I've looked at how that works in the sequencer. We've got a very high liveness feedback loop with your instrument, but a much lower one with everything else that goes on in the DAW, the GUI and the visual notations. Trackers, who's heard of trackers? Okay, yeah, I thought that'd be quite popular in the room. This is a high liveness environment. You do a little edit, you listen to the edit, you go back. You're continually listening to music while you're making edits, so that's high liveness. And here we go, in programming, the IDE, it's quite low liveness. Okay, you write all your code, you see, you compile it, possibly have to go and make a coffee while you compile it, then you can run it, then you get the feedback, then you can go back. So liveness is really important, and you know, we don't necessarily want that interaction, that iterative design and hacking of software. Sometimes we do want to be correct, but when you're ideating or when you're learning, you want that immediate feedback, okay? So that's what this talk is about, and the different questions are all about making music or programming more accessible to musicians and people who think audio. So the first question, what if MIDI was a programming language? Okay. What is MIDI? Well, MIDI is a real-time serial communication protocol for controlling devices. So, I quite like MIDI. I don't know if I'm a minority in this room. There's a secret, quite like MIDI. It's very, very hackable, very, very simple. Great for fritzing and things like that. It has its limitations, we all know that. It's designed for a live context and capturing performances, okay? So, it's a machine language, so it's not human readable. So not a great candidate for being a programming language. It is real-time and it's live stream. You have no way of accessing past events and no way of accessing future events, and that's kind of important when you want to script things in time and you think about music notations. It's raw musical data. So the events that anybody just don't have an address. They kind of like just, this is a C at this velocity, but when? On what instrument? You know, you need to look elsewhere and you need to keep a running status and context elsewhere outside the language. It's very, very low level. So it doesn't have the abstraction power that we look for in a programming language, okay? This is the pitch at the moment. This is the volume at the moment. If you want to change the volume, you send, oh, this is the pitch at now, okay? So you can't say, well, I want volume to increase over 5 minutes for, to this level. So that's a problematic when you think about how you make a programming language. It's serial and sequential, so you can't randomly access events. And even files are literally, the storage medium are literally just serialized live performances, okay? And ultimately, that means it's oriented to performance, Okay, it's not actually supporting notation, editing, or composition. So if we want to do that, and of course we do that with sequencers and music editors, we'll transcode it to our own proprietary internal data system, and how many sequencers and editors save in MIDI? They save in their own formats. So MIDI probably isn't the candidate to become a programming language, but it supports visualizations and notations that are great candidates. But before we talk about those, what is programming? Well, programming is a set of executable instructions that generates or processes data. Okay? I'm trying to be as generic as I can because there is a lot of different opinions on this subject, so you may disagree with them, but you'll see why I'm using these phrasings. Here's the most important thing about programming. It's an abstraction tool. Okay? You can abstract patterns and structures in the data using programming, and you abstract processes about how you change that data. And that's, you model a language, you've got a data model for a domain, you model the functions that you can do to that data, and here's the other thing that's really important. You generally abstract time, and that gives you control of time. So it's real time, you can't do that because you're living in time, but that's one of the powerful things about programming. So what that means is we abstract complexity, we reduce complexity, we automate things so that we can do more, and that raises the expressive ceiling of what we can express with just raw data. And it's a way of expressing dynamic processes that respond to context. Now, the best programs, the best expressions and algorithms are ones that you can write once and use in many, many places for many, many different situations. But what makes a good programming language? Speed, it's always about usability. Okay? Nearly all programming languages can do everything. You know, they're all Turing complete, but who cares? Can they do them easily? Can you do them efficiently in practice? Okay, are they practical? So the usability of programming languages is actually what we've got to think about. Okay, so let's think about a musical programming language. Okay, and let's think about the general idea of what is a notation. Okay, it's a set of executable instructions that generates or processes data. It's a tool for abstracting patterns and processes in music, okay? And so when you look at sheet music, for example, you've got the notes that you can see in MIDI, but you've got functions and operators that affect them over time, okay? And you have this abstraction of time as well. And I'm not just talking about sheet music and Western music. It's any representation that supports interaction in a domain. And so in music, we have lots of different ways of expressing data and processes. And these are all ripe to be turned into programming languages. There you go. The musical spreadsheet, the tracker. So here's a big problem. We have this disjunction. We have the world of mainstream computer music practice, which is about editing music, about MIDI, about recording, about DAWs. It's about just manipulating data. It's very concrete representations of everything, static works, linear time frames. And the music is very versatile music. It supports popular styles from classical to EDM to everything. And it's designed for musicians and people with musical knowledge. And it's designed to be easy to use. And then we look at, well, what's music programming then? It's almost the opposite of that. Instead of talking about data and patterns in data, we're talking about data processes for generating data. The data actually gets hidden. Okay, it's in memory somewhere. It's the process that you see in code. It's much higher level, it's more abstract, it's process-oriented, and it's harder to do the kind of musical aesthetics in programming languages, which means it tends to be, at least at the moment, a more experimental, avant-garde aesthetic when you see performances and practices. And it's very technical, okay? Music programming languages are better for music, but it still requires technical minds to get your head around it. So it doesn't appeal to the end user. And that's really where I want to focus. I want to bring the power of programming to the end user. I want sequencer users to be using programming and getting into code, and maybe even using it in their work. So end-user programming is a style of programming language that is designed for non-programmers or beginning programmers. And examples include macros and scripting technologies and automation technologies, VBA, and even in spreadsheets, formulas, okay? There are a lot of different types of programming tool, and these are kind of a series of metaphors for what programs are or programming languages, how they treat programs. And they might be more abstract or less concrete, and they might be more human-centric, more computer-centric. And if we're looking for something that suits an end user, a human, it's going to be further this end. And we want to, they're used to being in the concrete end, but we want to move them towards the abstract end, but we want to be sitting somewhere in the middle. So here's the ideal space for an end user programming language. And just next to it is the most successful paradigm in end user programming. The most popular programming language that everyone's used, Excel. Okay, why is that the case? Well, first of all, it's not the code that's visible, it's the data that's visible. Okay, it's a lot easier to get your head around, and it's a lot easier to understand what your code has just done because you've just seen the data change. You can edit that data directly. Okay, it uses kind of traditional interaction methods. It's just editing, basically, that people are used to. Formulas are this lovely piecemeal way to engage with code. You can have a spreadsheet and ignore code. You don't have to use it if you don't want to. Or you could use one formula. It's a really easy threshold to get into code. Or you can, in Excel, have an absolutely crazy amount of formulas that go completely generative, that do things like, well, who's seen the door inside Excel spreadsheet? Someone actually wrote a door inside Excel. Okay. Apparently there's also a flight simulator hidden in there somewhere. One of the really powerful things about spreadsheets is how easy it is to address data. And that's because it's a grid. Okay? Just simple Cartesian coordinates everyone can get their head around, which means, I mean, that's effectively pointers, right? You can point to other data in your data space with just a letter and a number. So those coordinates are actually the key to enabling really powerful expressions, but easily accessible expressions. Right. There is, of course, a myriad of music programming technologies, and each of these metaphors have an expression in the musical world. So something I've looked at and analysed. You can see, I don't know if you can see that, but you've got everything from sequences and doors in the human-centric concrete corner down to music programming languages down here that are functional or imperative, or just data, basically, or lists of events, you know, very computer-centric or machine-centric representations like MIDI. So spreadsheets, good end-user system. What's the corollary of that? It's the tracker. The tracker, the musical spreadsheet. It's got everything a spreadsheet has without the ability to do your accounts. But it has one thing a spreadsheet doesn't have, and that's formulas. So that's what the Manhattan Project is, okay? It is basically you can put in the cells, you can put your notes, or your musical data, your events and things like that, and that's what you're normally looking at. The data is visible, you can edit it just like any other music editor, MIDI editor, sequencer. And then you can open up a cell to add as much or as little code as you want to add. And that code is normally hidden. So you'll see the effect of that code as soon as you press enter and you see the data change. So it's really, really easy to understand how the code works, really, really easy to learn it. And you can use one expression, no expressions, or your whole piece could be algorithmic. It hides some other things like the relationship between data. So the Manhattan program will basically, when you reference another cell, it will just draw a line to it, okay? And you'll see, it's really great. So this is a beautiful visualization of a piece. It's kind of like, oh, I can see the structure of the music, how that's copied from there, and that's patterns, and it's repeats, and that's changes, and it's actually very beautiful. We'll see it in a second. So it's scalable. It gives you a low threshold, a high ceiling, and a shallow gradient. You've probably heard these holy grail terms in user interface design before. The one thing it adds to spreadsheets, time, okay? Time is down the rows of the pattern, and this is the execution time. So unlike a piece of code which is executed in milliseconds, you actually get it executed in musical time. So again, it kind of breaks down how a program, piece of music, is changing over time, and it's really easy to get your head around. And of course, here's the grid, okay? And this is what enables this to be a really powerful concept. It makes it really, really easy to address other events and past events, future events, other notes in the chord and things like that. And that's where the name comes from, okay? It does not come from the atomic bomb project. It comes from what we call rectilinear distance in computer science, which is called Manhattan distance. Manhattan was also the birthplace of process-based music and experimental music with Steve Reich and things like that, and this is that as well. It's trying to encourage musicians to think of music as not just patterns of data or patterns of notes, but processes as well. So there is a whole continuum of applications that you can use this for, from I just want to sequence my music to I want to go fully Neo, fully Code Ninja, fully algorithmic, and everything in between. And that's kind of what's lacking in a lot of other technologies, whether they're end-user technologies or programming technologies. They support the extremes, but not the middle of that continuum. So I could talk more about the project, but I'm actually just going to play you the trailer. And then the trailer itself was entirely generated by the program itself. So even the graphics and the video are generated. The orchestra's going to tune up. That's procedurally generated tuning up. We have a little more volume, thanks. So this is going to tell you a little bit more about what Manhattan is by, running Manhattan, basically. Okay, so I gave you a sense of it. I'm now going to give a very, very quick live demo of the environment itself and tell you about some of the things I've been using it for. So this is Manhattan. It's a spreadsheet. But what I use it for is teaching my students who come in as musicians and aspirant music producers how to code. And my course teaches C++, okay? So it's a hard sell. And if you start that in the first week, you'll lose the students. If you teach all of C++, the syntax, before you start giving them the ability to do synthesis and effects and plugin making, you lose them, okay? So you've got to now think about how you get people into coding. And so they'll do it through a MIDI sequencer that supports code. And so the tutorials inside it, the full curriculum that explores concepts in computer science, loops, if statements, arrays, variables, closures, lambda functions, threads, input and output, and all that thing through the context of music. And mostly, these are about completing familiar pieces of music by sprinkling in a little bit of code. So New Order by Blue Monday, Outcast's Hey Ya, some John Williams music and things like that. So it's should be a really immersive and really fun way to learn the principles of code, but at the end of it, you have that knowledge of all the key ideas in computer science. And actually, what I've been using it for first-year undergraduates, but recently also taking it back earlier, because we need to engage people earlier if we're going to increase diversity in programming. And so I've been taking it with BBC to colleges and into schools, and kind of making really simple exercises and little games and cards where they explore ideas and concepts in music or in programming. So here we go. I'm going to do one of these exercises. Here we go. So get a bit of a piece of music, and we've got to complete it using code. So let me, I need to change the audio output. Let's just go with all outputs. Awesome. And so this is actually the power of procedural music. It's all about patterns and loops. So you can capture a whole piece of music in a single bar. So here's what I'm going to do. I'm going to do the first exercise by going to A. And that's what the student has to do. If the counter equals 3, set the pitch in the cell labeled bass to D4. But if it's 4, let's go to an F. Wait for it. Okay, so there's our bass line. Third exercise. So that's the idea. You engage people who are passionate about music, and you use their passion for music to get them passionate about code. So I'll switch back here. This has been around for a while. I've been developing this for 10 years now, since the first prototype. So what have I been doing with all my time, and why haven't you heard about this yet? Because I am in a silo in academia. but I've been used in academia extensively, and it's just been, it's on a course to public release now. It's on Steam, it's free, so just type in Manhattan to Steam, and it's in early access at the moment, but there will be a public release soon. And it's mostly about, in academia, you can develop prototypes and cool ideas, but the quality assurance, there's just no funding for that, right? That takes time. So I've been doing various interesting projects, but mainly I've been using it for pedagogy. Okay, and teaching my students and teaching them code, teaching younger people, and so forth. One of the key aspects of that is they learn all of these ideas, the syntax of Manhattan, and then their assessed assignment, their coursework is pick a piece of music, any piece of music, and recompose it as code. Okay, so I'm just going to play one. So this is student work, just to show you basically what the students get up to and what you can reduce to patterns and processes. And so on. So yeah, the pieces I ask for 30 seconds and I get 12 minutes because they get addicted. They're in flow. Okay, they're passionate about code. Excellent. Let's completely disabuse them of that and introduce them to C++. That'll be the next question. It is a really important part of basically starting people on their journey to code. And so it's an important part of the degree program that we're developing at Point Blank Music School, the Music Systems Engineering program. And that is, this is the spiritual home of that course. We are going to make more of you people, okay? And we want you people to be involved in it as well. So please come and see our poster and tell us about what you think we should be teaching to get people ready to be a professional audio developer. So I used it for art and things like that. I did BBC Music Day. I took over Bristol Station in 2018, and I used machine vision to track people on the platform and then generate music in Manhattan, and that was good fun. And it was going to be in the Elb Philharmonia in 2020. And then, yeah, that wasn't a great time for crowd-driven music during a lockdown. So, but it is going to be a permanent exhibit in our new engineering building. So it's going to be permanently playing and generating music conducive to study in our new engineering building. Yeah, that's quite a challenge to write music that lasts and plays forever. The killer application, though, is something I've been looking at more recently, and that's game music and procedural music that reacts to context. And so developed a tech demo, and I'm now supporting Unity. So you have this really, really tight bond between what's going on in the game and what you can do in the music. Everything from, I could just sequence something static, or I could change that note, or I could layer stuff like you can do in Fmod, or I could do anything, right? I could just transpose the whole piece, or I can make it atonal suddenly, or whatever you like. And the Ars Arcus is a demo application to show what's possible, and so it's a game. But what I've done is I've put some NPCs into the environment that are playing the music. The orchestra's there, okay? So you can see them playing the individual notes of the soundtrack that's been generated, and naturally you can interfere with that, okay? So yeah, let's kill them, okay? Remove the instrument, that's too easy, you can do that in Fmod. What about if you wound them? Or then they they don't play as well as they did before, surprisingly. They start playing wrong notes, or they squeak. So here we go, just a quick excerpt of the game. You want to turn the volume up a little bit, please? That poor flutist. So here you go. In time with the music, and it knows the harmonic context, so the bell is also picking from the current music. Okay, and now I turn my ire to the band. There's a lot of fun to be had in procedural game music. Don't have any god complex or anything, I promise. So, you know, more instruments come in now. I'll spin this on, I don't have a lot of time. Oop. Who put that barrel there? And so on. So yeah, as I say, Unity support is something I've developed, and I'll be releasing SDKs and packages for that. So just a very quick preview of that. This is Unity, a demo of how you embed Manhattan in there and how you communicate. So I'll just run that with a vaguely recognizable tune that is thankfully not copyrighted. So there you go, you can see the game knows every note that's going on, is notified of all the notes that happen, so it could respond to that, but can also make changes. So there we go, I've cued a variation, but it's only going to do that at the right moment. In the meantime, you can change whatever you like. Very, very difficult to do this with audio clips. Here comes the variation. Background is just a MIDI sequence, so I can write as much manual as I want, or I can code as much procedurally as I want. We can go faster. And here we go. It's not easy to change key in those technologies at the moment. It's not a problem here. We'll just randomly change to a new key. And so forth. So there's documentation, and I'm really interested. If you're interested in game music or on procedural game music, please do email me, because I'm looking for testers and people with new ideas to develop this and see what it's capable of. Right, okay. I need to speed up a little bit. What if C++ had audio semantics? Well, it doesn't. It's a general purpose language. It is wonderful for audio, but it is not designed for audio. It's got significant abstraction power. It's a very powerful language. That's why we love it. But it's very hard to get into. It's not great for beginners at all. The IDEs themselves, the tools we use to write it, are really complicated. They're a whole extra level of complexity that the learner will just run away from. It's style agnostic, which makes it possible to do good style and bad style very easily. So it's a high ceiling, but it's a high threshold. Okay, so how do we get people there? Well, this is the problem, okay? In education, the burden is so much so that learning C++ is literally driving students away from universities, okay? They leave the course, they fail the course, they're demotivated. And actually, the digital skills of young people these days is dropping because of iPads, tablets, game consoles and web apps. They don't actually use computers. They don't learn computers. They don't even know what files and folders are anymore, okay? That means the cliff edge that C++ is even higher. And so universities are increasingly removing code from their programs or pushing it back. It's the first-year content becomes second-year content and things like that. It is a significant problem that I don't think we realize the scale of just yet. So how do we make C++ more accessible to programmers? Well, there's clearly a need for this. Soul is trying to do that. It's trying to make an audio language. It's trying to make it more accessible, more universal. Faust is a way of audio people being able to generate C++ code, albeit slightly unreadable C++ code, but very fast. And C major, obviously, is the spiritual successor for Soul that, again, is trying to improve what the tools we have for efficient programming in C or whatever language. So here's something else that C++ is. very adaptable. Okay, so mongrel language is a bit like the English language, saying, oh, that language over there is doing something cool, let's add it to C++. But it means that you can more or less write a new language in C++. So Clang is the next step. It's a dialect for C++ that allows you programmers to express audio processes in something close to the language they would use. It's a single header include that you can use in any C program, anywhere in any C++ program, and then you can just start writing kind of like signal processes and things like that. And this is still pure 100% native C++. So it has all the performance of C++. You don't have to abandon all your C++ code base or anything like that to start using it. And it's great for beginners because it's got a low threshold. It's easier to learn. You can even use this without learning all of C++. So we can do that thing. Let's do synthesis and effects and have some fun with code before we teach you about all the different aspects of the syntax and semantics. Okay, and here's the principal idea. So it's about polymorphism and operator overloading to just provide a bit of syntactic sugar. So we all know the string operator and the stream operator for files and strings. Well, this basically just adapts that for audio. Okay, so you can have a signal, a modulation signal, which is a 3 Hertz LFO, change its amplitude and offset it. Then the input audio goes through a filter, which is modulated using that modulation signal and goes to the output, okay? And that compiles down just to C++. Well, it is C++. It's entirely C++. But it actually, behind the scenes is plain old data. So it just becomes float and double operations. If you want to have a play, it's early days. I'm looking for feedback. I'm going to be using it in a lot of different projects and really flexing it and see what it's capable of. But it's open source, so if you want to grab the header and give it a go and give me some feedback, and if you want to contribute to the project, please pop over to GitHub and have a go. The plan is basically, I'd like to have a repository of reference implementations for DSP just on the internet somewhere that you can dial up and say, well, how do you do a Moog filter? I say, I can look at that, I can understand it just by looking at the code, but I can also, with this, just copy and paste it into my C project. So I talked about, there's another problem with learning C, and that's learning Visual Studio, okay? So even when you fix C and make Clang, you've still got all of this other stuff, right? So here's the last challenge. Is what if you could develop C++ plugins, not in Visual Studio, but in a digital audio workstation, okay? And so here you go. This is Rapid, Rapid Audio Prototyping Integrated Development Environment. And what you see there, it's a VST instrument, okay? So this is a synth plugin. You load it up in any DAW, and it just acts as a supersaw in this case. But you can expand the window and say, oh, hello, I can look at nice little analysis plots and so forth. And then there's this curious little button, which says Edit C++. You can click that because you don't like the way it sounds, and you see the C++ source code behind the plugin. You can edit it, you can change it, and then you can click Build. It'll build it in the background, and then hot swap it with what's running. So even without restarting the DAW, or even stopping playback, you can code C++, basically. So this is really great, obviously, for learners, because it's a lot simpler than Visual Studio, but it's actually a really great tool for rapid prototyping. So for just playing around with ideas, where we would have used a real-time environment, maybe like Max or Pure Data or something like that, now C++, that feedback cycle that has decreased, that liveness has increased, and you can do that more or less with C++ now. And I certainly tend to think more in C++ when I'm prototyping these days. So, what is it? It's actually a Clang LLVM toolchain entirely in the plugin. It's been very, very much optimized, so it's about 200 megabytes, the whole thing. You download it, it's very easy to install, very portable. And yeah, you just use it, and you can literally just copy and paste the C++ code you have here into your other projects or into Visual Studio. And at some stage, I'll add a button, which is kind of like Generate Juice Project or something like that. So that's have a demo. So here we go. Out of time.
Yeah, maybe we can leave 1 minute for questions.
2 minutes, okay. I will do this very, very quickly. This is obviously the host, and there's the edit C++. And if I play that, let's not do that one. Let's switch over to Clang so you can see an idea. And then I'll hit build. So this is just a plugin running in a host. And it's compiling it, it's building it, it's there now, right. There's actually not a lot of code there. That's the whole synthesizer, and quite a robust synthesizer. And you can see it's very, very easy to just mess about, experiment with, and learn code. And that's basically it. So the idea is liveness has improved, and that's how we're basically supporting this degree program. This will also be open source. I'm going to release it on GPL next year. Please email me now if you want to be testing versions of it, you want to be trying it. It's obviously early days, but yeah. Come and see our posters. Also come and learn about how we're using this on the Muse program for the first year to get people up to scratch with C++. Thank you very much.